A matrix obtained by interchanging the rows and columns is called the transpose of a matrix. So from 1 and 2 we can say that A minus B whole dash is also equal to A dash minus B dash. Transpose of B and transpose of A multiplied B dash A dash, you will get the answer LHS is equal to RHS. So a square matrix A is equal to A, Ij is said to be a symmetric matrix if A dash is equal to A. Dear student, welcome to the mathematics section. I am Mr. Niranjan, Faculty of Mathematics, Vidhyaashram PU College. Now in this session, we are going to discuss regarding the problems based on transpose of a matrix. In the previous classes, I have discussed regarding transpose and some problems based on transpose. Now in detail, we are going to discuss regarding the problems based on transpose of a matrix as well as the symmetric matrix. Now, let us come to the problems based on transpose of a matrix. So, you know the transpose. A matrix obtained by interchanging the rows and columns is called the transpose of a matrix. It is denoted as A dash. A dash is the representation of a transpose of a matrix. So, if A is a matrix, if A is a square matrix or any matrix, then the transpose of this is denoted as A dash or A power T. So, if A is a matrix of order m cross n, then the transpose of this matrix will have the order n into m. Now, here, let us take this problem. If A is equal to 3 root 3, 2, 4, 2, 0 and B is equal to 2, minus 1, 2, 1, 2, 4, verify that A plus B whole dash is equal to A dash plus B dash. Now, let us find out first A plus B. Addition of matrices 3 root 3 2 4 2 0 plus matrix B 2 minus 1 2 1 2 and 4. Let us add these two. So ordinary addition, first element with first element, second with second element, third element with third. So 3 plus 2 is equal to 5. Root 3 minus 1 it is. Plus into minus minus, root 3 minus 1, 2 plus 2 is equal to 4. Now, 4 plus 1 is equal to 5 and 2 plus 2 is equal to 4, 0 plus 4 is equal to 4. This is A plus B. Now, what is required to find in the LHS? A plus B whole dash. Now, LHS left hand side, A plus B whole dash is equal to the transpose of this matrix. So, first row becomes first column 5. Root 3 minus 1 and 4 and second row becomes second column 5, 4 and 4. This is equation number 1. Now A plus B is equal to A matrix A plus matrix B. Add the corresponding elements. 3 plus 2 is 5, root 3 minus 1, 2 plus 2 is 4, plus 4 plus 1 is 5, 2 plus 2 is 4, 0 plus 4 is equal to 4. Now transpose this. So, A plus B whole dash is equal to first row becomes first column 5, root 3 minus 1, 4 and second row becomes second column 5, 4 and 4. Now, right hand side on the other hand, find out A dash. A dash, the transpose of A. So, the transpose of A is 3, root 3 and 2. First row becomes first column and second row 4, 2 and 0. This is A dash. Now, coming to B dash is equal to the transpose of this matrix. First row becomes first column 2, minus 1 and 2 and second row 1, 2 and 4. Now RHS, let us take RHS. RHS is equal to A dash minus B dash. A dash minus B dash. So this is equal to A dash. Substitute the value of A dash. A dash is equal to 3, 4, root 3 and 2. 2, 0 minus plus, this is plus 2, 1 minus 1, 2, then 2 and 4. This is minus 1. Now, add these two. So, if I add 3 plus 2 is equal to 5, 4 plus 1 is also equal to 5. Again, root 3 plus into minus minus 1, this is root 3 minus 1. 2 plus 2 is equal to 4. 2 plus 2 is also equal to 4, 0 plus 4 is equal to 4. So this is equation number 2. So A dash plus B dash is equal to 5 root 3 minus 1, 4 and so from 1 and 2, verify that, observe that from 1 and 2 equations, from 1 and 2, see, right hand side are equal, 5 root 3 minus 1, 4 and 4. So therefore from 1 and 2 we can say that A plus B whole dash is also equal to A dash plus B dash. This is A plus B whole dash is equal to A dash plus B dash. For same problem, if I take the negative sign, A minus B whole dash is also equal to A dash minus B dash. So let us take A dash minus B dash for this. Now this is A plus B whole dash is equal to A dash plus B dash. Now second problem, verify that subtraction, I will go for subtraction. A minus B whole dash is equal to A dash minus B dash. Now first find out A minus B. LHS A minus B. A minus B. What is A? 3 root 3 2 4 2 0 minus B 2 minus 1 2 1 2 and 4. So this is equal to 3 minus 2 is 1, minus into minus plus, root 3 plus 1, 2 minus 2 is equal to 0, 4 minus 1 is equal to 3, 2 minus 2 is equal to 0, 0 minus 4 is equal to minus 4. Now transpose this, A minus B whole dash is equal to, the transpose of this, first row becomes first column 1, root 3 plus 1, 0, second row becomes second column 3, 0 and minus 4. Let us represent this as equation number 1. Now coming to this, straight away find out A dash minus B dash, right hand side. The transpose of A is equal to 3 root 3 and 2. This is 4 2 0 minus transpose of B. Transpose this matrix. First row 2 minus 1 2 becomes first column. Second row first becomes second column 1 2 and 4. Subtract this. So 3 minus 2 is 1. 4 minus 1 is equal to 3. Next, root 3 minus into minus is plus. This is root 3 plus 1. 2 minus 2 is equal to 0. Again 2 minus 2 is equal to 0. Minus into minus, 0 minus 4 is equal to minus 4. So this is A dash minus B dash. This is equation number 2. Now what do you say from equation number 2? 1 3 root 3 plus 1 0 0 4. 0 minus 4, 1, 3, root 3 plus 1, 0, 0 minus 4. So RHS are equal, therefore LHS is also equal. So from 1 and 2 we can say that A minus B whole dash is also equal to A dash minus B dash. So these are the two problems very important for 2 markers. So A plus B whole dash is equal to A dash plus B dash and A minus B whole dash is also equal to A dash minus B dash. Now let's come to the second problem. So this is very important problem for 5 marks. This is 5 marks questions. So very important. So you may expect this for 5 marks. Now what is given? If A is equal to minus 2, 4, 5, B is equal to 1, 2, minus 4, verify that AB whole dash is equal to B dash A dash. AB, multiply AB and transpose it. Then transpose of B and transpose of A multiplied B dash A dash, you will get the answer. LHS is equal to RHS. Very easiest, but don't get confused while solving this problem. So let us write down AB first. A, what is A? Minus 2, 4 and 5. And what is B? B is equal to 1, 2, minus 4. So before going to the multiplication, check whether it is possible to multiply or not. So write down the order for this. 3 rows and 1 column. This is 1 row and 3 column. These two are equal. So the matrix you are going to obtain is of order 3 rows and 3 column. So 3 rows and 3 column matrix you are going to get. Now just listen here. This is first row, first column, second column, third column. First row, first column, second column and third column. Minus 1 into 1, minus 1 into 2, minus 2 into 1 is minus 2. Minus 2 into 2 is minus 4. Minus into minus plus 2 4s are 8. Again, second row, first column, second column, third column. 4 1s are 4. 4 2s are 8. 4 4s are 16, minus 16. Again, third row, first column, second column, and third column. 5 1s are 5, 5 2s are 10, again 5 4s are 20. This is AB. Now transpose this. The transpose of this is AB whole dash is equal to the transpose. First row becomes first column, minus 2, minus 4 and 8. Second row, 4, 8 and minus 16. And third row becomes third column, 5, 10 and minus 20. So this is equation number 1. Now AB whole dash is equal to this much. Now let us come to the right hand side. Find out what is right hand side. Right hand side is B dash and A dash. Now what is B dash? The transpose of B. Write down the transpose of B. 1, 2, 4. First row becomes first column. 1, 2, minus 4. And A dash, the transpose of A. First that column become row. That is minus 2, 4 and 5. Now this verify whether it is possible to multiply or not. So this is 1, 2, 3 rows, 1 column. Again this is 1 row and 3 column. These two elements are equal. So you are going to get a matrix which is of order 3 rows and 3 columns. Similar multiplication. This is 3 rows and 3 column. First row, first column, second column, third column. 1 into minus 2 is minus 2. 1 into 4 is equal to 4. 1 into 5 is 5. Next, second row, first column, second column, third column. 2 into minus 2 is minus 4. 2 into 4 is 8. 2 into 5 is 10. Again, minus into minus plus. 4 2s are 8. Again, minus 4 4s are 16. Again, minus 4 5s are 20. So this is equation number 2. B dash into A dash. Now from 1 and 2, see from 1 and 2, so right hand side minus 4, minus 2, 4, 5, first row minus 2, 4, 5, and second row minus 4, 8 and 10, third row 8, minus 16 and minus 2. Right hand side are equal means definitely right hand side, left hand side. If right hand side are equal means definitely left hand side also equal. Therefore, from 1 and 2 you can say that AB whole dash is equal to B dash into. This is called as a reversal law of transposes. This is called reversal law of transpose. So usually you will expect a question like this for 5 marks. So this is a little bit confusing. Don't get confused while solving this problem. Usually what students will do while doing this problem, so they will add minus 2, minus 4 and 8. They will put minus 2 minus 4 is minus 6 plus 8 is equal to like this 2. Again they will add 8 plus 6 is equal to 12. 12 minus 6 is equal to 12 minus 6 is minus 4. Again 10 minus 20 is minus 10 plus 5 is minus 5. They will write like this. Actually this is not possible. This is wrong. So if you multiply this, before multiplication check whether it is possible to multiply or not. So then only you can multiply and you are going to get a matrix of order 3 rows and 3 columns. This is a very important problem. Now next come to this problem. Same type problem. What is given? If A is equal to cos alpha sin alpha minus sin alpha cos alpha, prove that A into A dash is equal to A dash into A is equal to A. Any matrix into transpose or transpose matrix into the same matrix, if you multiply you are going to get a matrix which is equal to an identity matrix. Here I is an identity matrix of same order. A dash into A. A dash, the transpose of this is cos alpha sin alpha minus sin alpha and cos alpha into the given matrix, same matrix, that is cos alpha sin alpha minus sin alpha and cos alpha. Multiply this, usual multiplication, first row first column, second column. This is equal to cos into cos is cos square alpha, minus into minus plus, sin into sin is sin square alpha. Again cos alpha sin alpha minus into plus minus sin alpha into cos alpha. Next, second row first column second column, sin alpha cos alpha minus cos alpha into sin alpha. Next, sin into sin is sin square alpha plus cos into cos is cos square alpha. So this is sin square plus cos square is 1. These two gets cancelled. Minus and plus. 0. Again these two gets cancelled 0 and is equal to 1, that's equal to an identity matrix. So A dash is equal to, therefore from 1 and 2 what do you say? You can conclude that A into A dash is equal to A dash A is equal to A, I, an identity matrix. So if you multiply A and A dash, you are going to get an identity matrix. This concept is very important while solving the problems in invertible matrices. Now next, come to the next problem. Next concept we are going to study is symmetric and skew symmetric matrices. Symmetric matrix and skew symmetric matrix. This is very important concept. Usually you will get 1 3-marker question from this concept, symmetric and skew symmetric. Now let us know the definition of a symmetric matrix. What is a symmetric matrix? So a square matrix A is equal to A, I, J is said to be a symmetric matrix if A dash is equal to A. The transpose will remain the same. If A dash is equal to A, if you transpose the matrix, you are going to get the same matrix. Such a matrix is called a symmetric matrix, symmetric with respect to the principal diagonal. So that means Aij, that is Aij is equal to Aj for all I and j, for all the values of I and j. So in other words, it's a square matrix in which all the elements above the principal diagonal must be equal to elements below the principal diagonal. So all the elements above the principal diagonal are equal to all the elements below the principal diagonal. If you fold this matrix along the diagonals, all the above elements, these elements will coincide with all the elements below the principal diagonal elements. So these elements will coincide. So 4, 5, 6, 4, 5. 4 coincides with 4, 5 coincides with 5, 6 coincides. So all the elements above the principal diagonal must be equal to all the elements below the principal diagonal. If I transpose this matrix, transpose of this 1, 4, 5, first row becomes first column, second row becomes second column, third row becomes third column. So 1, 4, 5, 4, 2, 6, 5, 6, 7, A dash is equal to A. So the transpose will remain the same. So if such is the case, such a matrix is called a symmetric matrix. That means a square matrix in which all the elements above the principal diagonal must be equal to elements below the principal diagonal. That is A dash is equal to A. If you transpose, you will get the same matrix. Such a matrix is called as a symmetric matrix. A dash is equal to A in case of a symmetric matrix. Let us take another example. If A is equal to 4, 5, 4, 2, then transpose of this A dash is equal to A dash is equal to A dash 4, yes, A dash of this is nothing but the transpose of this A dash is equal to, so 4, 5 and 4, 2, same you will get. So A dash is equal to A. Suppose if A dash is equal to this matrix, the transpose of this, if I transpose this A dash whole dash is equal to same matrix, we are going to get 4, 6, 6, 7, right. So in general, if A is equal to 1, 2, 2, 4, then the transpose of this is A dash is equal to 1, 2, 2, 4. The same matrix you are going to get. Such a matrix is called as a symmetric matrix. Now let us come to the skew symmetric matrix. A square matrix A is equal to Aij is said to be skew symmetric matrix if A dash is equal to minus A. If A dash is equal to minus A, that is for all ij elements, Aij is equal to minus of Aj for all the values of I and j. Whereas if I is equal to j, Aij is equal to A of minus ji, provided principal diagonal elements are 0. That is 2, A11 is 0 means A11 is equal to 0, A22 is also equal to 0, A33 is also equal to 0. So in case of a skew symmetric matrix, all the principal diagonal elements are zeros. See here, this is an example for a skew symmetric matrix. All the principal diagonal elements are zeros and all the elements above the principal diagonal must be equal to elements below the principal diagonal but opposite in sign. So A is equal to 0, 4, 5, minus 4, 0, 6, minus 5, minus 6, 0. The transpose of this is 0. If I transpose 0, minus 4, minus 5, 4, 0, minus 6, 5, 6, 0, you are going to get a negative matrix, that is A dash is equal to minus A. See here, this is plus, 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 here it is minus, minus and minus. So that means A dash is equal to minus A. Such a matrix is called a skew symmetric matrix. So all the elements in the principal diagonal are zeros and other elements above the principal diagonal must be equal to elements below the principal diagonal, but they are opposite in sign. Let us take one more example for a symmetric, skew symmetric matrix. If A is equal to 0, minus 2, 3, then this is 2, 0, again 4, minus 3, and minus 4, this is 0. So let us take another example. A is equal to 0, minus 2, 3, 2, 0, 4, minus 3, minus 4, 0. See, all the elements in the principal diagonal are zeros, and the elements above the principal diagonal must be equal to elements below the principal diagonal, but opposite inside. This is minus 2, plus 3, minus 3, plus 4, minus 4. If I transpose this, the transpose of this matrix is equal to 0, minus 2, plus 3, and 2, 0, 4, minus 3, minus 4, and 0. That is A dash is equal to minus A. So such a matrix is called a symmetric, skew symmetric matrix. If A dash is equal to A, then it is called a symmetric matrix. If A dash is equal to minus A, then it is called as a skew symmetric matrix. Now let us take a problems on this skew symmetric matrix. So in skew symmetric matrix, one more example, all the diagonal elements, all the elements in the principal diagonal are zeros, and other elements are equal but opposite in sign. So the principal diagonal equal elements below the principal diagonal but opposite in sign. Take one more example. If B is equal to 0, minus 2, minus 3, 0, 1, 2, minus 1, 0, and 0, minus 3, 2, 3, 0, minus 1, minus 2, 1, and 0. So this is B dash is equal to minus B. This is also an example for a skew symmetric matrix. So B, see, all the elements in the principal diagonal are zeros, and other elements above the principal diagonal are equal but opposite in sign. So if you transpose, the plus 3 becomes minus 3, minus 2 becomes plus 2, and plus 1 becomes, so it will convert to the negative matrix, minus. So the best example for a skew symmetric matrix. Now let us come to a problem. Let me solve one more problem which is based on transpose of the matrix. That is very important. Let us solve one more problem. If A is equal to, this is 5 marks question. 5 marks question. If A is equal to 1 minus 4, 1 minus 4 and 3, B is equal to minus 1 2 1, minus 1 2 1. Prove that or verify that AB whole dash is equal to B dash A dash. Same problem which I did. Now let us find out AB. So 1 minus 4 and 3, minus 1, 2 and 1. So I told in the beginning itself. So for multiplying such type of matrices, check the order whether it is possible to multiply or not. This is 3 rows, 1 column, 1 row and 3 column. These two are equal. Then the matrix you are going to get is of order 3 rows and 3 column. Don't get confused with the matrix multiplication, because this is only 1 row, 1 column, 2 column, 3 column. Second row, first column, second column, third column, third row, first column, second column. So 1 into minus 1 is minus 1, 1 into 2 is 2, 1 into 1 is 1. Again, minus into minus plus, 4 ones are 4, minus 4 twos are 8, minus 4 ones are 4. Again, 3 into minus 1 is minus 3, 3 into 2 is 6, 3 ones are 3. Now transpose this. If I transpose LHS, that is minus 1, 2 and 1, 4, minus 8, minus 4, minus 3, 6 and 3. So this is equation number 1, minus 1. Now come to the right hand side, left hand side. Come to the right hand side, RHS. That is reversal law of transpose, B dash into A dash. Now write on B dash. What is B dash? Minus 1, 2 and 1 into A dash. A dash is equal to 1, minus 4 and 3. So again same, first row, first column, second column and third column. So this is equal to minus 1 into 1 is minus 1, minus 1 into minus is plus 4, minus 1 into 3 is minus 3, minus 1, 4, minus 3. Second row, first column, second column, third column, 2 ones are 2, minus 2 fours are 8, minus 2 threes are 6. Again 1 ones are 1, 1 fours are 4, minus 4, 1 threes are 3. Check. This is equation number 2. From 1 and 2, if right hand side is equal, means left hand side is also equal. So therefore from 1 and 2 we can say that AB whole dash is equal to B dash into A dash. AB whole dash is equal to B dash and A dash. So this is a 5-marker question. Definitely you will get a question for 5 marks from this part. Now take a similar problem. If A is equal to 0, 1, 2 and B is equal to 1, 6, 7, verify that or prove that AB whole dash is equal to B dash into A dash. So same, LHS take AB is equal to A, 0, 1, 2 into 1, 6, 7. Check whether this is 3 rows, 1 column, 1 row, 3 column. So the matrix you are going to get is 3 rows and 3 column. Multiply first row, first column, second column, third column. 0 into 1 is 0, 0 into 6, 0, 0 into 7 is 0. First row, all elements are zeros. Second row, 1 into 1 is 1, 1 into 6 is 6, 1 into 7 is 7. Third row, 2 into 1 is 2, 2 into 6 is 12, 2 into 7 is 14. Transpose this. The transpose of this AB whole dash is equal to the transpose. First row become first column 0, 0, 0, 1, 6, 7. Second row becomes second column and third row 2, 12 and 14 will reduce us to third column. This is equation number 1. Now right hand side B dash into A dash. What is B dash? Transpose of this is 1, 6, 7 into A dash. A dash is 0, 1 and 2. Now that is equal to same 3 rows 1 column, 1 row 3 column. So you are going to get a matrix of order 3 rows 3 column. 1 into 0 is 0, 1 into 1 is 1, 1 into 2 is equal to 2, 0, 1, 2. Again 6 into 0 is 0, 6 into 1 is 6, 6 into 2 is 12, 0, 6, 12. Again 7 into 0 is 0, 7 ones are 7, 7 twos are 14. This is equation number 2, B dash into A dash. So therefore from 1 and 2, you can say that from 1 and 2, AB whole dash is always equal to B dash into A dash. AB whole dash is equal to B dash into A dash, reversal law of transposes. This is very important problem. Now that's for the today's session. We'll meet again in the next session with different problems, some theorems based on the symmetric and skew symmetric matrices. Thank you.